Okay, welcome to part 2 of 4.0. Now we're going to actually be factoring. So remember with factoring, we're always asking ourselves, what can I take out? It's basically going to be the opposite of what I did in the first video. So I'm going to start by doing an example on factor by grouping. When I'm looking at number 7, I'm asking, is there something that can divide out of all 4 terms? And the answer is no. You can't take a 7 out because this and this don't have 7s. And you can't take an x out because that doesn't have an x. So in a case like this, what I'm going to do is take the first 2 terms and group them, and the second 2 terms and group them, and then I'm going to say, okay, what can I take out of each pairing? So I'm looking at this first one, and I see that both of them have an x squared at least. They have 2 x's that can come out. So whatever it is you think that you can divide away from both terms, you're going to write that on the left here. So I think both of them can divide away an x squared. So if I had 3 x's because I had x cubed, I took out 2 x's. That's going to give me just 1 x left over. And if I have 7x, I'm just dividing away this x squared, right? So if I have 7x divided by x, 7x squared divided by x squared, my x squareds effectively cancel, and I'm left with just a 7. I know I did this step correctly, excuse me, because if I tried to work it backwards, I would get, and like distribute back in, I would get x cubed plus 7x squared. Okay, so you can kind of do a quick mental double check there. Okay, but first, I need you to do the same thing here for the second set of parentheses. The only thing that can come out of this one is a 1, I think. So let's take out a 1. I'm going to go ahead and, hopefully, normally you'll actually get to take something out. But in this case, you only take out a 1, which leaves me with just an x plus 7 right there. And this is where something pretty epic happens. Check this out. They're the exact same. These are literally just really, really fancy like terms, okay? Random example time over here. If I said I had, 2x plus 3x, you would say, oh, easy, that's 5x. Well, how'd you get that 5? You took the 2 and the 3. So, for just a second, I'm actually going to rewrite that as the 2 plus the 3 to get to that 5x, right? Well, that's all that this over here is. It's just that instead, I'm having 2x plus 7 plus 2x. I'm sorry, I guess in this little thing I've got a 3 going, don't I? It's the same thing. It's just this time instead of a boring x, it's an x plus 7. So my answer here would be that same 2 plus 3 with my x plus 7s. Here's the 2, here's the 3. You have a total of 5 x plus 7s. It's a lot fancier looking over here on the left, but that's all that we're doing. So let me kind of get all that stuff erased here. Get rid of that there. Okay. So since this and this are the same, you only have to write it once because you're just combining like terms, right? And then, well, what are you combining? Well, you're combining this and this. So that makes up your other parentheses, x squared plus 1. This is my answer. You've basically done the anti-FOIL. If that was a word, that's what you've done, anti-FOIL. If you wanted to, you could go back through and distribute or FOIL. You would get this answer up here. And that's how you could know that you did it correctly. Okay? Example 8. To do example 8, let's go back to notes from the previous video. And let's look at number 1. Do you notice that, well, not number 1, I'm sorry. Let's look at number 2. Do you notice that this middle number is just those 2 numbers added together, and the last number is again those 2 numbers multiplied together? That information is going to be important because that's how you can actually do the anti-FOIL on a problem like number 8 here. What you need to do is figure out what number did you add to here. So underline that. That's going to be a -1. And what number are we multiplying to? That's a -2. If you remember from back in the day, I like to make a chart for this, and then I just start thinking of the numbers that work. So 1, and I start at 1. 1 times what will give me -2? And the answer is -2. And then I say, okay, does that work or not? 1 times -2, yes, that is -2. And is 1 plus -2 a -1? Yes. So actually, those are my numbers. Cool. X plus 1 and x minus 2 is the factored form, or the antifoil, of x squared minus x minus 2. And if you wanted to, you could go back through and distribute or FOIL, and you would get the exact same answer up here. Now this is important. What I just did with this table and going directly and plugging it in only works if a equals 1. Okay, so you notice that there wasn't a number here written next to x squared. Let's see what happens in a case like problems from groups 9, 10, and 11. I got 2 of them here for us. Notice that this time x doesn't equal 1. It's going to start off the exact same, where I'm going to make a table for the most part. Number 7 and number 8 are going to get combined to be like one mega problem to solve these 2 problems down here. So here's how it works. What you're going to do, take the a value, or the number that's next to the x squared, multiply it by the c value. I'm getting that ABC from, like, if it was ax squared plus bx plus c, take a times c. That's how you'll find that written in a book. So 3 times 35 is going to be 105. That is the number you're going to multiply to this time. You're still going to add to the same number, but you're going to multiply to a different number. Other than that, it's going to work out the same way, where I'm going to start with 1. 1 times what gives me 105? And of course it is 1 times 105, which does multiply, but that does not add to 22. So then I do the next one. 2 times what is 105? And I'm only going to work with whole numbers. And 2 times a decimal gives me 105, so I'm just going to cross it out. All right, 3 times what gives me 105? It would be 35. But that does not add to 22. So it's not that. Because I'm multiplying to an odd number, I know that no even number is going to work. So that means 4's out. 5 times what is 105? If you're not sure, just take 105 divided by 5 and you will get 21. But that doesn't add to 22 either. 5 plus 21 is not 22. 6 is out. 7, 105 divided by 7 is 15. 7 plus 15, that's 22. Finally have my numbers, woohoo! Okay, now last time when you had your 2 numbers, you were allowed to just plug it in, yippee-ki-yay. Today, or on this next problem, that doesn't work. And again, the reason is because a doesn't equal 1. That changes the rules. Here's what you're going to do this time. You're going to uncombine like terms using those 2 numbers. So here's what we're going to do. Take the 3x. Let me get a different color going. Take the 3x squared, write it down. Then, instead of writing 22x, you're going to uncombine like terms using that 7 and 15. So add 7x plus 15x. Okay, that's where those came from. And then just do plus 35. That's it. That's how that next part comes out. Then from there, what you're going to do is do like you did on number 7. You're going to, we call it factor by grouping. So I'm going to come back here and do the first 2 terms together and the second 2 terms together. Looks like I can take an x out, which gives me 3x plus 7. Looks like on the next one, maybe I can take a 5 out, which gives me a 3x, plus 7. How handy-dandy is that? Looks like I get to do my fancy schmancy combining of like terms, the really fancy combining of like terms. Like so. On this next one, it works out the exact same. It's just going to play with some negatives. So if you want to stop watching here, I won't blame you if you feel like you got it. One thing I do want to show you real quick on this factor by grouping. Let's pretend, I'm going to make up an example down here real quick, that when I'm on this step right there, when you got to that part, let's pretend for a moment that what you ended up with was actually this. When you combine like terms, they absolutely have to be the exact same. And these are not the exact same because these ones are both positive and these ones are both negative. But what if, hear me out, I had taken out a -5? That would have allowed me to then have some positives. Now that they're the same, my answer would be x minus 5 and 3x plus 7, okay? That was just an example there. So, okay, I'm going to go ahead and do this one over here because it does some more negative things. You're good to watch or not. Again, first step is to multiply. So this time I'll be adding to 7, but multiplying to -18. And I start at 1. 1 times what is -18? It is -18, but that does not add to 7. 2 times what is -18? That is -9. That adds to a -7. I'm looking for a +7. I think, actually I know, when you get to a situation where you got the right number but the positive negative was wrong, just take where you're at and flip the signs. So check that out. If I do a -2 times a +9, that is still a -18, but now it will add to be a +7. So now those are my numbers. I'm going to bring down this 2x squared minus 2x plus 9x minus 9. Uncombining those like terms and just bringing that number down. And now what I can do is factor by grouping. So I bring out a 2x. That's just going to give me an x minus, ooh, it all canceled. That's just an x minus 1. And how about a 9? Bring out a 9, and again, that's just going to give me an x minus 1. So my final answer is 2x plus 9 and an x minus 1. And again, here's where that stuff came from.